So function f is defined by a polynomial. Some values of x and of x are shown in the table above. Okay, which of the following must be a factor of f of x? All right, on a scale of 1 to 5, definitely level 5. Tough problem, but I think the biggest thing to learn from this is going to be what polynomials and factors, the relationship between polynomials and factors. So let's start with something really basic. If I have 6, what are the factors of 6? 2 and 3, because 2 times 3 is 6. Similarly, if I have a polynomial such as x squared plus 3x plus 2, it also has factors. X plus 1 times x plus 2. Because when I multiply out x plus 1 times x plus 2, it'll give me x squared plus 3x plus 2. Similarly, how over here I have 2 times 3, which will give me 6. So factors of a polynomial are two quantities. When I multiply those out, they'll give me that actual equation. Let's take this one step further. X plus 1 and x plus 2. What are the zeros here? The zeros are going to be x equals negative 1 and x equals negative 2. Just because I'm going to set this equal to 0 and set that equal to 0. So zeros are x equals negative 1 and x equals negative 2. And in a parabola, a zeros really just mean where that parabola crosses the x-axis or where the y value is 0. So in order to connect everything together, and this is where it gets really, really important, factors of a polynomial are where the zeros are. So again, the factors of a polynomial is where the zeros are, or where the y value is 0. See how at this particular point the y value is 0 and over here the y value is 0? So factors of a polynomial is where the parabola has its zeros. So in this case, the factors are going to be at x equals negative 1 and x equals negative 2, which is where the zeros are. One last time. Factors of a polynomial is where the parabola has its zeros. Keep all that stuff in mind. Let's translate that over to this question now. F of x is the same thing as the y values. So these are all my x values and these are all my y values. Remember what I said before. The factors of a polynomial are where the y value is 0. So where's the y value 0 here? At 5. So x equals 5 is a factor of this polynomial, because that's where the y value is 0. Now, which of the following must be a factor of x? Remember, in the other problem, my zeros were x equals negative 2 and x equals negative 1, right? So one of the factors was x plus 2, and the other factor was x plus 1. So similarly, I can draw the same exact connection here. So if x equals 5 is one of my zeros, then a factor will be x minus 5. Because if I were to work the other way around and I gave you a polynomial such as x minus 5 times x plus 2, I'm making the second one up, and I asked you what the zeros were, you would say x equals 5 and x equals negative 2, right? So if you know that a zero is at x equals 5, a factor must be x minus 5. One phrase to remember, a polynomial is going to have factors at its zeros. So wherever the y value is 0, that's where it's going to have its factors. So in this case, the y value is 0 at x equals 5, so that means the factor must be x minus 5. That's all. Level 5 problem. Tough problem, but again, watch this a couple of times, really try to understand the connection, visualize the parabola, wherever it's crossing the x-axis, those x values, that's where the factors are. So if that x value was, for example, let's say that x value, let's try this out. Let's say that x value was negative 7. Let's say that x value was 1. What would the factors be of this particular example in this parabola? You would say the factors would be x plus 7 and x minus 1. Those would be the two factors of this particular polynomial or parabola. So parabola or polynomial has factors at its zeros or where the y value is 0.